After getting your goggles and setting up a paper towel placemat, it's time to get a piece of copper wire and mass it on the electronic balance that reads to the 10,000ths place. Record that mass in the data table on the top of page 6. Get a 250 milliliter beaker, label the white spot with your initials and your lab period, and then mass the 250 milliliter beaker on the balance that reads to the 100ths place. Record this mass in the data table on the top of page 6. Mass out about 1 gram of silver nitrate on the electronic balance that reads to the 100ths place. Record the exact mass of this silver nitrate in the data table on the top of page 6. Use a 100 milliliter graduated cylinder to measure out 100 milliliters of distilled water. Add the distilled water to the 250 milliliter beaker. Add the crystals of silver nitrate to the water inside the 250 milliliter beaker. Stir the solution with the glass stir rod until all the crystals have disappeared. Be sure to answer the question after step 8 in your lab packet. Was the disappearance of these silver nitrate crystals a chemical or physical change, and why? If it is not already done for you, form a coil of copper by wrapping it around your pencil several times. Place this coil of copper in the silver nitrate solution. Allow the beaker to sit for a period of time while you make observations and interpretations of those observations. You can see what happened in the beaker during this time-lapse video over a 30-minute span. Here is the copper coil after 24 hours in the silver nitrate solution. Make some additional observations and then pause the video and go through the process of figuring out what that gunk is all over the copper wire. List the formulas of the substances used in the lab and then use your observations to determine the identity of the gunk. Shake the crystals off the copper wire. Then take the coil out of the solution and rinse it with some tap water. Shake off the excess water, dry the copper coil with a paper towel, and make sure all the gunk is off the wire. Mass the wire on the electronic balance that reads to the 10,000ths place. Record this mass in the data table on the top of page 6. Get a 150 milliliter beaker, label it in the white spot with your initials and your period number, then carefully decant the blue liquid from the 250 milliliter beaker into the 150 milliliter beaker. Make sure the solid stays in the 250 milliliter beaker. Now, rinse the solid in the 250 milliliter beaker with tap water, mix it with a stirring rod, let the solid settle and decant the rinse water down the sink. Then repeat this process one more time before placing the 250 milliliter beaker in the oven to dry out the solid crystals, and the 150 milliliter beaker under the heat lamps to evaporate all the water from the solution. You can see here that a pale blue solid remains after all of the water is evaporated from this solution. The next day, you should have a 250 milliliter beaker with dry silver in it and a 150 milliliter beaker with some blue-green solid in it. Place the 250 milliliter beaker on the balance that reads to the hundredths place. Record this mass in the data table on the top of page 6. At the end of part 1 of the experiment, the data table at the top of page 6 should look like this. Use the data to determine the change in mass of the copper wire and the mass of the silver solid. Use the observations that you made and the data that you collected to answer questions 1 through 11 on pages 4 and 5 of the lab. Do the best you can, but a little ground-dwelling rodent told me you might have some trouble with these questions.